Let us consider when light ray traveling from one medium to other medium. First we will calculate the deviation produced. Deviation of light ray traveling from one transparent medium to other transparent medium. Let us consider ray is traveling from rarer medium to denser medium. Optically denser, optically rarer. Refractive index of rarer medium be mu r, refractive index of denser medium be mu d. Now light ray is entering from this. What are the various angles of incidence? First thing is light can incident normally where angle of incidence is 0, and go on, angle of incidence can be varied. We can consider up to the grazing instance here, means variation of angle of incidence starting from 0 to this, means at different angles ray is incident. Now as the angle of incidence is increased, what happens to angle of refraction? Now we will see how the variation of deviation with angle of incidence. So let us consider a ray is incident at an angle theta I. This is incident ray in the medium rarer medium. Rarer medium where refractive index is mu r. Now in the denser medium, what happens? When ray entering from rarer to denser, it bends towards normal. Therefore, refracted ray will go like this. This is angle of refraction. Now, in the absence of this boundary, if the medium continues to be same, if there is no change in the medium, there is no boundary separating two media, or there are no two media, only one medium is there, light would have continued to move like this. In the absence of second medium, light would have continued in that way, but because of the presence of second medium at the boundary, it is undergoing a change in direction here. So this angle is called deviation angle. That is called deviation angle or angle of deviation, deviation angle. So instead of going straight, because of the presence of second medium, it is bending like this. This bending angle, what we call it as deviation angle. And this angle is, total angle is theta I, and the angle at which it is refracting is theta r. Therefore, deviation angle from the graph is theta I minus theta r. Deviation is anti-clockwise. Deviation is anti-clockwise as seen from denser or rarer medium when light ray going from rarer to denser medium. This is the deviation. But as per Snell's law, mu sin theta I divided by sin theta r is mu of denser with respect to relative. Denser medium relative to rarer medium. As per the definition, it is mu dA by mu RA. Or we can write, A is common, we can write mu d by mu r. You can avoid writing A. Always whenever we write single letter, it is other letter is assumed to be relative to air or vacuum. So it is refractive index of denser medium and refractive index of rarer medium. These two are absolute refractive indices. Substituting here, what we get, mu rarer medium or the rarer medium in which ray is instant medium refractive index multiplied by sine of the angle of incidence is equal to denser medium refractive index or refractive index of the medium in which refracted ray lies into sine of angle of refraction. From Snell's law, we can write like this. This is based on Snell's law. From this, we can calculate theta r. Theta r is sin theta r is equal to, therefore sin theta r is equal to mu r by mu d into sin theta I. Therefore, theta r is equal to mu r by mu d sin theta I and sine inverse function. Sine inverse is theta r. Sin inverse mu r by mu d sin theta I is theta r. So therefore, deviation from this, deviation produced in this case is theta I minus theta r, theta I minus sin inverse mu r by mu d sin theta I. Okay, that is the deviation angle. Deviation angle depends on angle of incidence. For different angles of incidence, deviation angle is different. For cases, two extreme cases we consider. For normal instance, what is the angle of deviation? Theta I is 0. Therefore, delta I is 0. There is no deviation when the angle of incidence is 0. That is normal incidence case, there is no deviation. Next case we are going to consider other extremity is for grazing incidence. What is meant by grazing incidence? Ray is, incident angle is 90 degree. It is the surface separating the two media, ray is, incident ray is grazing. That is theta I is 90 degree. Pi by 2 radians. Angle of incidence is 90 degree with the normal. In such case, how much is delta? Delta is, this is pi by 2 minus sin 90 degree is 1. Sin inverse mu r by mu d. That is the extreme value. So, as the angle of incidence varies from normal incidence theta is 0 to grazing incidence theta is pi by 2. Deviation angle varies from 0 to pi by 2 sin inverse mu r by mu d as delta as a function of theta. How to represent this variation of deviation angle with angle of incidence in the case of light ray travelling from rarer to denser medium? Plot will be as shown. That is, we are plotting a graph between angle of incidence theta I and angle of deviation delta starting from 0. For 0 angle of incidence, deviation angle is 0, means graph starts at the origin and it is going to change up to theta I pi by 2 and delta corresponding to this delta value is pi by 2 minus sin inverse mu r by mu d. Mu r by mu d. That is the variation. In between it is a sin inverse function and it is difference of theta I and sin inverse. Therefore, the graph will be asymptotically reaching here, concave down. So, with concave down we will be getting this. So, this is how the variation of deviation when light ray travelling from rarer to denser medium, variation of deviation angle with the variation of incidence angle. So, this graphical representation, this is a variation and this is mathematical expression for variation of delta with theta I. So, that is one. Now, in case if light ray travelling from denser to rarer, second case is when the light ray travelling from denser to rarer, what happens to the deviation we will consider now. Consider a boundary, plane boundary. Let there be a denser medium, a rarer medium. Let mu r is the refractive index as rarer medium. Let mu d be the refractive index of the denser medium. And here it is normal. How the ray is incident? There are possibilities. Normal instance to grazing instance. Variation of theta I from 0 to pi by 2. 0 case is normal instance, pi by 2 case grazing instance. When theta I varies from here to here, what happens to delta deviation? So first we will consider a particular angle of instance, theta I. As we know, as the ray enters rarer medium from denser medium, it bends away from the normal. Theta r is greater than theta I. So corresponding to first ray deviation. What is the deviation produced? In the absence of the second medium, ray would have continued in the original direction like this, but because of the presence of second medium,